Hi everybody, Miss Rose here. Going to do another video for the math focus area associated with this physics project. It's called Algebra Review, and this will be a video about objective number 1, which is entitled Determine and Interpret the Slope and Y-Intercept in a Linear Relationship. Okay, here we go. I'm going to share my screen, go to the whiteboard. Now, a linear equation is represented by the formula y equals mx plus b. And if we look at that linear equation, I'm just going to draw an equation out here. It's going to give us a line. That's why it's called a linear equation. And so I'm just going to draw a graph in the most basic way. And I'm just going to label this the x-axis and label this the y-axis. And then I'm going to put some marks here, okay? And some marks here. Okay. And so there's our line, okay? All right, so B is often also called, not often, always, often, very often, always, called the y-intercept, and that's here. That is the place where the line crosses the y-axis. That's why it's called the y-intercept. That's the place where it intercepts the y-axis. Now, in order for it to do that, x must be at 0. Here's where x is 0. Here's where x is 1, 2, and 3, and 4, and 5. Okay? Now, if x is 0, then this goes off, and y just equals that b value. There you have it. So this b is the place where this line is going to cut across that y-axis. So here, it's actually 1. Here is the slope, okay? And the slope is actually how steep the line is. If the line rises to the right, it has a positive slope. If it goes down, as this line does, oopsie, then it has a negative slope. Okay? So we see that this line has a positive slope, and we see slope, or m, is also the rise over the run. And by rise, we mean how much does it rise or fall? So this is really y, right? A change. This delta sign means a change in y over the run, a change in x, okay? And we'll take a look at that for this particular graph. In this particular graph, we go up 1, so that's our rise, which would be 1, let's say, and we go over 1. As we go up 1, we're also moving over 1. Again, up 1, over 1, up 1, over 1, okay? So this is actually 1 over 1, or 1, okay? So our slope is 1. So this equation can be rewritten as y equals 1x plus, and remember our b is our y-intercept, 1. And that is the equation of the line that's there, okay? That is a linear equation. So here we've identified the slope and the y-intercept. So let's take a look at how we would write linear equations. And when do we even use linear equations? Are they useful in life? Well, you bet they are. Take a look at this. A cell phone provider will allow you to buy a phone over time. They require a $50 initial payment and then charge you $25 a month. If the total amount paid was represented by a function for the total amount paid over time, what would be the y-intercept? Okay. So they're asking us for this b value, the y-intercept. Okay. So let's really think about this. The y-intercept is that one-time initial payment. It doesn't change as the number of months go by. It's a one-time payment. So here we know that b, or our y-intercept, is 50. But what is our slope? How would we write this equation? Well, our slope is what's changing. Our slope is the $25 per month is represented by 25x plus 50. Okay? This is how we'd write this. So for the first month, it would be 25 times 1, or 25, plus 50 would be $75. The second month, it would be 25 times 2, which is 50, plus 50 would be $100. So this here shows you how this factor, this m, tells you how much you're increasing as you go across each month. You're increasing by 25. This is the slope of that line. That's your m. Here's the place where you start. Here's the place when you don't even have any months. Before you even start using the phone, you have to pay the $50. So this is your b, or your y-intercept. Okay? Any questions about that? I'm going to now bring another question over and see if we do more questions, it'll help us to kind of understand. Okay, so right now I'm going to erase what we have here, but I'm going to leave our y equals mx plus b, just so that we know what the slope is, and we can get rid of this question. Okay, very similar question, and let's read it. A county fair charges $5 for tickets and $2 for each ride. A line is drawn representing the total cost after each ride. What is the slope of this line? Okay, so to get in, each person has to pay $5, right? But for every ride, you have to pay an additional $2. So let's look at what our equation is, okay? Our equation is going to be, remember, the things that changes is our slope. So our equation is going to be y equals $2 for every ride plus $5 to get into the county fair. There's your ticket. This is per person. If you wanted to just get in and have no rides, so this would be 0, 2 times 0, it'd just be $5. The answer here, this is 0, this is 5, the answer is just $5. But let's say you wanted to ride 4 rides. Well, then you're going to have to pay $2 for every ride, plus the $5 to get in. You're going to need, this is 8 plus 5 is, you're going to need $13. Okay? Now, again, this is the flat rate, the 5 to get in. This is what's varying based on the number of rides you want. So it's asking us for the slope of this line. It's a linear equation because it's in this form. And we know that the slope is our m value, the value right before x. It is positive. So the answer is 2. Fairly easy. Okay. Now, let me ask you to take a look at this problem. The cost of parking a car in an hourly lot can be represented by the following equation. Y equals 3x plus 2. Linear equation, it's going to give us a line. What does the 2 tell you about the cost of parking? Okay, so we know that the 2 is the value that doesn't change. Just like it's $5 to get into the fair, but it's $2 for each ride, here it's going to be $2 to get into the parking garage and then $3 an hour. This is what's going to change. This is your slope. Every hour, we go up $3. So just to pull in and park before the time has even started cost you $2. This is just to get in to the lot. So what does the 2 tell you about the cost of parking? There is a $2 fee. To get into the parking lot. Okay? Make sense? Let's try one more and see how we do with this one. Okay? This one says a bike rental company charges a $5 service fee and $1 per hour. If this situation is represented by a function, what would be the y-intercept? So again, we're going to create a linear equation that says y equals mx plus b. And we know that whatever is changing is our slope. So what's changing here? $5 service fee, $1 per hour. The per is the thing that's changing. It depends. It's $1 per hour, but if it's 5 hours, it's $5. So that gives you a good hint as to this is what is changing. So it's 1x. Every hour, we're going to add on another dollar, but there's $5 to service these bikes once you return them. So here is this equation. And we know that the B is the value that doesn't change. It's the flat rate. It's the $2 to park in the garage. It's the $5 to get into the fair. It's the $5 that's a flat service fee, no matter how many hours you have that bike. If you have that bike out an hour, it's a $5 service fee. If you have that bike out 10 hours, you're still going to pay a $5 service fee. This doesn't change. The thing that changes is always our slope, okay? Our slope here is usually per hour or per ride. That number gives us the slope of our line, and it also gives us a value that changes based on the x, okay? Now let me see if I have another situation here. All right, here's one. Last one of this type, then we'll look at 2 graphs. It says a rental car costs a one-time fee of $25 plus $3 per hour. Okay, let's represent this by a linear equation. What is our one-time fee? Our 25. And we know that that is our y-intercept. That is our b. That is what we pay at time 0. Before we even drive the car off the lot, we've got to pay the 25. But what changes is the amount we pay due to the hours that we're going to have the car out of the lot. So again, we're just going to write it like we've written everything else. Y equals, we know that slope is 3. We know that every hour is 3, but we don't know how many hours. Until we know how many hours, we can't know that value. But we know the one-time flat fee, it's 25. And so before we even drive the car off the lot at 0 hours, we owe 25 bucks. At 1 hour, this is just going to be 1 hour. 3 plus 25, we're going to have 28 bucks. And it's going to keep going up and up and up like that, depending on how many hours we have this car. $3 an hour, it's going to go up, okay? And there we have it. I don't know if you can see that's an 8. Terrific. So this is linear equations. Sear this into your memory. Y equals mx plus b. B is your y-intercept. M is your slope. The slope can be positive, going up to the right, or negative, going down to the right. Okay, I'm going to stop sharing there, and I'm going to share some other things. The first thing I want to share is let's take a look at, here we are, this graph. This is Miguel's savings in months, okay? I'm going to ask you now, what is the slope of this line? Well, let's see. We know that slope is rise over run. We know that this line is rising to the right, so it's positive. So let's see where we go. Let me just start at 0 here, okay? I'm going to go up 10, 20, 30. So we've gone up 30. So our top number is 30. And then how far? Rise over run. How far across do we go? 1, 2 months. Be sure you look down here because each box does not represent 1 month. It represents half a month or 0.5. So we've got $30 over 2 months. So it's $15 a month. And so the slope here is 15. Let's just check it out. Over the next 2 months, we go up from 30 to 60, so another 30 over 2 months, 15 a month. So our slope here is 15. We rise 15, we go over 1. We rise another 15, we go over 1, okay? We're reducing that 30 over 2. Let's look at, I'm going to stop sharing here, going to go look at a different document now. Going to take a look at this. This is a soccer ball being kicked into the goal. So at 0 time, the soccer ball is 5 meters away from the goal. Within 5 seconds, boom, it's no meters away from the goal. It's in the goal. What is the slope of this line? Well, the y-intercept is 5, y equals mx plus b, and that tells us it's 5 meters from the goal. The slope is going to be rise over run. We know it's a negative slope because it's going downhill, but we're going to go down 1 and over 1. So it's a negative 1 over a positive 1, so it's negative 1. So our slope here is negative 1, okay? Again, this is the focus area called Algebra Review. This is objective number 1, determine and interpret the slope and y-intercept of a linear equation. Hopefully this is a review. If you have any questions, text me or email me and I will help you through this focus area. Okay? Best of luck, everybody.